Here we are in section 3-3 with the solutions to number 7 through number 16. Number 7, fill out the table for each of the following. So we're going to take these numbers, stick them back in as a review question. Stick in 2x plus y equals 9, take x is 5, stick it in right there, and we get 2 times 5 plus y equals 9. That's the equation of sticking in the 5. Subtract 10 from both sides, and we get y equals a -1. Okay, good. Next one, now we're going to stick in x as -4. So that'll give us 2 times a -4 is a -8 plus y equals 9. And in solving this equation, we add 8 to both sides, and we get y equals 17. So that'll give us 17's partner. All right, the next one, we're going to take y as 3. So we've got to stick y as 3 in here. So we get 2x plus 3. Let's move it over here just a little bit so we can see it. 2x plus 3 equals 9. Subtract 3, we get 2x equals 6. Divide, and we get x equals 3. Oh, look at that. 3, 3. The next one, we're going to have 0 go in for y. So let's put that guy right up here, and we have 2x plus 0 equals 9. Divide by 2, and we get x equals 9 halves, or 4.5. And now that we've discussed intercepts, we realize this would be the x-intercept of this particular line. And the last one, we stick 7 in for y, and we get 2x plus 7 equals 9. Subtract 7 from both sides, and we get 2x equals 2. Gives us x equals a 1. There we go. That's filling out that table. And all of these points, 5, -1, -4, 17, 3, 3, 9, half 0, 1, 7. Those points, when coordinates put in parentheses like that, those are all points on this line. All right. Number 8, y equals 5x plus 2. We're going to stick 2 in for x, and we get y equals 5 times 2 is 10, plus 2 is 12. So y is going to equal 12. The point 2, 12 is on the line. The next one, stick in 0 for x. Y equals 5 times 0 plus 2. That was a nice one, and that's why intercepts are so cool. 0, 2 is the y-intercept of that because we stuck 0 in for x. Next one, stick in -1 for x, and we get, let's put this one up here top, we get y equals 5 times a -1 plus 2. -5 plus 2 is a -3. Gives us -3 right there. Good. Then the next one, we're going to stick in 0 for y. Ooh, y equals mx plus b. That's certainly a nice way to stick in x's. A little bit more difficult when we have 0 equals 5x plus 2. Subtract 2 from both sides equals a 5x, and divide by 5. Oh, look, those are back from -5. Oop, I did that backwards. -2 divided by 5. There we go, -2/5. This is an equation from chapter 1, and every single time you stick one in, solving to find the partner is exactly that problem. Good. The next one, 4 goes in for y. So this is going to be 4 equals 5x plus 2. So we've got subtract 2 from both sides, and we get 2 equals 5x. And divide by 5, we get x equals, oh, that's a positive 2/5. Fascinating. And there we have it. That's number 7 and number 8. Clear that off, and let's look at number 9 now. 9 says, graph the following lines and label the x and the y-intercepts. So we don't get to pick just any point we want on these ones because of these instructions, the x and y-intercept. We are going to stick in 0 for x. Let's do number 9. We'll circle that in this color. And then we're going to stick in 0 for y. That'll give us the x-intercept. So stick in 0 for x, and we get 3 times 0 is 0 plus 2y equals 10. Divide by 2, and we get y equals 5. And then if we stick in 0 for y, we get 3x plus 2y to 0 equals 10. Divide by 3 and we get x equals 10 thirds, which is about 3.333. So if we look at these 2 points, 0, 5 is about right up here, and 3.333, somewhere around there, that'd be all right. And then this line, little curvy there, that's the line. Good, with the x and the y intercepts labeled. Let's clear that off and go on to number 10. Here, we're going to stick in 0 for x, and that gives us y equals 2 times 0 minus 7. We just get a negative 7. I like that one. Stick in 0 for y. We get 0 equals 2x minus 7. Have to add 7 over here. Equals 2x. Divide by 2. We get x equals 7 halves. So 7 halves in our calculator is about 3.5. So let's see if we can find that. 0, negative 7, about down there. And 3.50 would be there. And notice we're right on these lines because of the zeros we placed for x and y. And so that guy, oh, no, that won't do. There we go. Ah, look at that. That was a good line. There we go. Good, that was number 10. Let's clear that off and look at number 11 now. Number 11 is y equals 1/2 x. All right, so we're going to stick in 0 for x. And we get y equals 1/2 times 0 equals 0. So 0, 0. Well, that's fascinating. And that kind of tells us if we stick in 0 for y, we'll get x is 0, and that's true. That is both the x and the y-intercept. Unfortunately, we don't know which way it's going right now, so we do need a second point, and this one wouldn't matter. We have now labeled the x and the y-intercepts. If you were to stick in x is 2 or x is 4 or x is 5, whichever point you choose, you can do that. If you stick 2 in there, you'll get y out as 1. If you stick 4, you'll get y out as 2. And so that will be the line. And any second point you would like to stick in, that's fine, as long as you have this labeled as the x and the y intercepts. Excellent. Let's clear that off. And the next one, number 12, we'll do in this color. So if we stick in 0 for x, we get 4 times 0 is 0 plus y equals 8. I'll write that out here. 4 times 0 plus y equals 8. And this is just gone. Y equals 8. So we get 0, 8. Cool. Now if we stick 0 in for y, we get 4x plus 0 equals 8. X equals a 2. Solve that, and we get 2, 0. So it looks about like this. Those are our two intercepts. No, not good enough. Tried going too fast. I still got that curve. Must be something with my joints, not being able to draw straight. Okay, there's a graph of that line. Okay, number 13. Let's do it in this color. So we have sticking 0 in for x, and we get y equals -3/7 times 0 is 0 minus 9. We get a -9 there. Excellent. 0, -9 is going to be way down here. And now let's stick 0 in for y. Oh, this looks like it'll be a little tougher. We have 0 equals -3/7 x minus 9. Add 9 to both sides. 9 equals -3/7 x. Times by, so divide by the -3/7 is the same as timesing by a -7/3, right? Dividing by a -3/7. Fractions, or if you wanted to, you could do it in 2 steps. You could times both sides by 7 and then divide by a -3. Punch that in your calculator and you get a -21. Oh, wow. Okay, so this is like, oh, I don't know, -10, -20. It's out here somewhere. Let's elongate that axis. Yeah, we're right there. Sorry for having to go through my all my work here. But Okay, I think you get the picture. That's about what it would look like. I should have zoomed out and put like -9 here, and then -21 would be, or -21 would be back out here. You can zoom in better on the one that you have for your answer, but that's what it would look like. So if we zoomed out, let's redraw where those two intercepts would be now that we know how big they are. And let's redraw that. Okay, so if we had -9 and we said, oh, let's zoom out, so that's like -20, so -9 is about right there. And then do the same thing we did, put 0 in for y, 0 equals -3/7 x minus 9, add 9, times by a -7, that's a -63 equals 3x, divide by 3, we get x equals a -21. -21 right there would be about there. There we go. And you see it's the exact same line. We've now just zoomed out a little bit. Excellent. Let's clear that off for number 14 now. Number 14, we'll do this color. Stick in 0 for x, and we get 2 times 0 minus 5y equals 12. Divide by a -5, and we get y equals -12/5. In the calculator, that's a -2.4, so about right there. Between -2 and -3, -12/5, let's write that guy in there. And now if we stick in 0 for the y, we get 2x minus 5 times 0, 5 times 0 is 0, so that just kind of, poof, is gone, equals 12. Divide by 2, and we get x equals a 6. So 6, 0 is about right out there. And so there are 2 points with a little blip in the middle. Imperfect line drawer, that's for sure. If you have a straight edge in graph paper, man, these can look really sharp. Excellent. Next one, let's go down to number 15. X equals 4. Now, if you recall on this, without the y, it sometimes throws you off and you're like, what is going on? But the points, if you make sure that x is 4, then y gets to be anything you want. Because that's the only requirement of all the points on this line, is that the x is 4. 4, 7, 4, -2, 4, 0. And so you'll see 4, 0 is right here. We'll go out to where x is 4, and then 4, -2, 4, 7. And you see that the x, where you're out there at 4, has to remain constant. So this is a vertical line, x equals 4. All right, now let's do y equals 3. So same idea. You can pick anything you want for x, but the y will always be 3. So 0, 3, 2, 3, -7, 3. I don't know why I picked those numbers, but anything 3. And you'll notice up where y is 3, you'll get this point right here. And then 2, 3, or -7, 3, or any number you wanted. If the y is always 3, it will always be right along those points right there. Excellent.